Okay, pylon induction. So is it possible to induce a voltage using a large coil underneath a power line carrying alternating current? We've got a magnetic field and a frequency, and they ask us what voltage, what area we would need to provide this voltage here. Let's start with Faraday's law. The flux is changing, so what I'm going to say is that the flux through my coil is going to be BA, and since it's an alternating magnetic field, there's going to be a sort of a sine or a cos element in there. So this is what we end up with. And we differentiate the sign. And this is a lot like the coil that's rotating in a magnetic field. We get NBA omega times minus sine. Well, technically it should be. Oops. It should be minus sine differentiates to. Oh, minus cos. Okay. And then that's it. Right, that's good. Now, we only want the maximum EMF, so we can get rid of this thing. We don't need that. So it's minus NBA omega. All we need to do now is find omega. We know already that omega is 2 pi f. 2 pi times 50. Well, that's just 100 pi. Let's just leave it like that, I suppose. And then all we need to do is rearrange for the area. So the area is the magnitude. We're just looking at magnitude, so I can ignore the minus sign as well. That's going to be the EMF divided by NB omega. Now for these numbers, I get 340. N is 1. Forgot to mention that. B is 4 times 10 to the minus 6. And the omega is 100 pi. So I get 270,000 meters squared, which is an impossibly large area, although I suppose theoretically it's possible.